Hello everybody, my name is Gintvilė Šimkonienė. I'm from Kaunas University of Technology, and our theme is collaborating with the Malta's research group. So our theme is about photovoltaics and electrical vehicles, mitigation on the low voltage distribution network in Malta. The main aim and objects to examine the possibility of high photovoltaic and electric vehicles penetration in low voltage systems and distribution network, utilizing a typical distribution network found in Malta as a case study, also to demonstrate the level of automatic mitigation achieved in Malta residence areas, to examination the effect of electric car penetration on a typical low voltage distribution network in Malta based on a Genius feeder with a PV combinations. So the main idea is when the requirements in all the world is from European Union that emissions should be lower more than 95% until 2050. So establish goals and directives to make the quiet models that distribution network also will be the part of this, and include a lot of photovoltaic and making some experiments and testing how to reduce and solve the problems of the overvoltages and overcurrents, charging relay causing undervoltages. And distribution network may encounter both variable scenarios on the same day, since photovoltaic generation and electric vehicles charging often occurs simulation, particularly in residential case studies. According to the nominal voltage standard, the range tolerance is plus minus 10%, and one of scenarios supposed does not tolerate any possible technical faults and takes 0, which flags violations as soon as simulation display a voltage problem. And if it utility cannot tolerate any possible voltages problems begin and starting from the 30%, when the likelihood is 0.1. The conservative scenario, when is 15%, and causes complications, probably equals 0.05. Utility will of your sum assess can determine the difficulties. And integration costs 78% and 80% of feeders to have downstream and upstream allocation concerns, and should think about the upstream and downstream possibilities, and also about the distribution network quality. Feeders with fewer than 50 customers and less than 0.5 kilometers have no concerns with photovoltaic and electric vehicles potential in both locations. So this insight may help utilities concentrate on longer feeders with more consumers. So conclusions, this paper was investigated the possible technologies constraint of photovoltaic and electrical vehicles integration on actual low voltage distribution network using real case situation and data. Voltage concerns are common in photovoltaic, where electric vehicle and integrated have overloading issues. This indicates the solution for one technology may not work for another. Also, combining photovoltaic and electric vehicle might elevate their technological issues. The decrease is small. Photovoltaic in electric vehicle charging peak don't consider it. In fact, was initiate technical issues earlier than photovoltaic. Was in a lot of research papers was discussed in both voltages and utilizations. Three factors aspects compared, and their combination would not mitigate the solution.
Thank you.